Welcome back to Slope. Today we're going to continue learning about slope. Yesterday we learned to find the slope of a line. We were given lots of graphs and we were, given the definition of slope and how to calculate a slope, and we calculated slopes and even more slopes. Today we're going to again be calculating slopes, but we are going to first need to draw the line in some situations, and in other situations we're going to need to learn how to interpret what the slope of a line represents. Now, before I get into the lesson, I'd like to quickly remind you that if you want to download a skeleton of the notes, you can on my website under where the note sheets are found and linked. Because there will be a lot of graphs and tables and things in this lesson, it doesn't hurt to download them and print them. Otherwise, you can feel free to take your notes in your notebooks, but remember, I will be checking them in class tomorrow. Let's get into the lesson. Just a quick review and reminder that slope is the rate of change between 2 points on a line. It's the change in y over the change in x, better known as the rise over the run for any line that is graphed. Okay, so in this particular graph right here, if I were to calculate the slope and I were to choose 2 points, the slope would be the rise, which is 2 boxes, over the run, which is 1 box, giving us this slope over here. Okay, there we go. Let's keep moving. So we're going to jump right into an example. The table below shows the relationship between the number of hours Carlos works and the amount of money he earns. Graph the data, then find the slope of the line and explain what the slope represents. Well, let's start with graphing. So a quick review of graphing. I think we've talked about this before, but a good reminder. Everything in the world depends on time. You cannot change time, you can't stop it, you can't fast forward it, you just can't change time. So we always graph our time on the x-axis. So in this case, this is what's going to go on x. And in this situation, how much money is earned definitely is going to depend on how many hours Carlos works. So the amount of money earned, that's going to be our y value. So let's start to graph the data. I know I'm going to be putting my time in hours on the x-axis. That's an x. And I'm going to be putting my earnings in dollars on the y-axis. Well, I know that I am going to be graphing increments of 3 on the x-axis. So that's 3. And then that right there, oops, let's get rid of that line that I put in there by accident. So that's 3 right there, that's 6 right there, that's 9 right there. Now I could have gone by ones. That would have fit on my x-axis, but since my table is done by 3s, I might as well just graph by 3s. Let me get rid of all of those little dashes. Okay. So then I know my amount earned is going to be going up in increments of 45. I know that that's an increase of 45 and that's another increase of 45. So let's go 45, 90, 135. So let's plot our points. I know that after 3 hours I've earned $45. After 6 hours I've earned $90. And after 9 hours, I've earned $135. So there's my line. I'm going to graph my line. So I'll put a line in. Let's make that line a little thicker so you guys can see it. Okay, so there's my line. I'm going to give my line an arrow at the end to indicate that it goes on forever. Okay, so we want to find the slope of this line. Well, nicely enough for us, we have 3 perfect coordinates that we can work with. So I know that if I were to calculate my rise over my run, going from this point right here to this point up here, I know I go up 1 box, but in this particular case, a rise of $1 is actually going to be $45. And a run of $1 is actually going to equal to 3 hours. So there's my run. All right, and this is because I've scaled my boxes to each equal 45 going up and 3 going across. So when I reduce this, I get that my slope is equal to 45, not 45, but when I reduce by 3, I get that my slope is equal to $15 for every 1 hour. So to answer the question, explain what the slope represents. In this case, the slope represents Carlos's earnings of $15 per hour. So based on this graph and this table, because Carlos is earning money at a constant rate of change, he's earning $15 an hour, I can get all of this just from looking at this graph and calculating the slope. All right, let's try another example. Ronaldo opened a savings account. Each week he deposits $300. Draw a graph of the account balance versus time. Find the numerical value of the slope and interpret it in words. So, unlike this example that just passed, in this example we were given our table, and from our table we came up with our graph. Alright, well in this example I am not given a table, and I am asked to come up with a graph. But the table is going to be easy to come up with. So we know that Ronaldo opened a savings account, and each week he deposited $300. So our two sets of data are going to be weeks and the amount of money in savings. So I know that if he started at week 0, he's going to have $0. But after 1 week, he deposited $300. After 2 weeks, he then deposited another $300, so that brought his savings up to $600. After 3 weeks, that brought his savings up to $900. And after 4 weeks, that brought his savings up to $1,200. So if I go to graph this, I know that when he first opened the account, he had $0. But after 1 week of having the account, he had $300. 2 weeks, he had $600. 3 weeks, he had 3 weeks, he had $900. And 4 weeks, he had $1,200. So there's my line. I'm going to draw my line and to connect those points. Okay, so there's my line. Now I need to calculate the slope. Well, I know I'm rising $1 for every box that I run. Based on the scale that I have here, each box is going to be a rise of 300, and each box going across, each run is actually going to be 1 week. So my slope, which is my rise over my run, is going to equal to a rise of $300 for every 1 week. And in this particular case, it's already reduced for us into a unit rate. So when I interpret this graph and I interpret what the slope means, my interpretation is that Ronaldo saves $300 per week. So if he never stops doing this, his money is going to grow at a very quick linear rate. All right. So let's take a look at our problem of the day, which will be the first thing we do upon entering class tomorrow, not today. Today, that would be funny. Anyway, it is tomorrow that we will be looking at these problems of today. You have one where you have the table and you have to graph it, and then the other one you have to come up with the table and then graph. Again, this can be found in the skeleton notes online on my website. So if you do choose to print just this one, you can, or if you choose to print the entire thing, you can as well. Alright, good luck, and I'll see you next time we see each other in class. Have a great night.